Okay, I think we're live now. Still setting things up. I think I'm not muted there. Yeah, I turned off mute. Okay, I got both of the chat windows set up. Oh, this is a Amazon problem. I should also put it in Amazon playlist. Got that. Should show up there. Okay. Oh, I shouldn't be covering the prompt. Yeah, there. All right, there's the prompt. This is a real Amazon senior SDE problem we're going to be covering today. I've got both my chat windows set up. I need to, tell the Discord channel. Okay, I should have that set up. I should you guys need an invite for the Discord. Um, Post that in the chat. Cool. Hi, Leo. Oh, does my voice sound weird? Yeah, let me know if you guys aren't able to hear me all right. All right, I think I got everything set up. I'm gonna go get a couple of things and we'll kick it off at 10:45.
अरे मैं इतनी देर से बोल रहा हूँ।
Okay, it is 10:45 p.m. I think we're good to get started. So I'm going to go ahead and get rid of this file. I see we've already got a question in the chat. It's a really good one, which is it going to be a real-time service? So that is actually something that was open-ended. I was actually kind of anticipating that to be something that could be a challenging aspect. That, like, so if you did go for real time, that would definitely be challenging. And so I did actually do a little bit of homework on trying to figure that out. And I'm still going through my notes a little bit for anything else. Yeah. So I'm going to cover both actually. And that one's actually going to be, yeah, that one's going to be challenging. So yeah, that's a great thing to specify though. There's a couple of different ways you can kind of make this vary. It's Steve from Life Engineered actually said that as an interviewer, you should try and like make a prompt your own. And that is definitely a way that I think somebody could do that. So I'm going to be trying to do that. How did I do this in my other MD files? I think I did it like that. Cool. All right. Link to the rescue. Yep, that's that. Yeah, that's actually, well, actually with this one, I don't think that would actually really help quite as much. Anyways, so this is taken from a real Amazon senior SDE interview. Somebody leaked it to me. I don't think the term weather app was actually mentioned anywhere in the prompt I was given. This is the actual full prompt that was given, is design a system that takes temperature readings from 1 million sensors across the state of Washington. They communicate over HTTP, display the data as a bitmap image, assuming each sensor represents a single pixel, no need to interpolate. Also need to be able to get the maximum and minimum for any particular day across the whole state. So yeah, that's the prompt. Yeah, it didn't say whether we were reading from the sensors once per day, once per hour. We also don't see the read volume, and we don't know if it's just like one snapshot per day or if it's just like, continuously updating the picture throughout the day. Lots of room for ambiguity, but all was given was this, which is cool because then that means I can kind of cover a couple of different variations with it. Yeah, I only have like some of the requirements there. There's a couple of things that I would also like to kind of touch on, is also what somebody said was real time versus once per day image variations. This is kind of like in the variations section is kind of how I can call that. And then it's also so it's like the rate at which the image is updating, and then it's also like do you like push the updates to their phone like a WebSocket kind of thing. And then also device failure, handling device failure. This was not mentioned anywhere, but like you need to be thinking about failures at the senior SDE level. Juniors designed for the happy path. There's nothing in there about device failures, but I think I have some ideas for that. So you want to cover that as well. This is my checklist. I never really cover. If you're going to interview at Google, you should be covering every single thing in this. I just don't have the heart to delete it, even though I'm so horrible at going through it. Anybody? I'm just checking the chat for any questions before we go ahead and get into the diagrams. Oh. Yeah, well, so you can actually take the same question and you can present it you can present it for multiple levels, and you would just get like varying levels of detail at each level. So actually for they actually have a system design prompt at Google. Amazon does not. Amazon doesn't have a prompt, but Google does. And at the senior level, you're supposed to give machine count estimates. At the staff level, you're supposed to also do latency estimates as just one little thing. I think that there's probably also similar variations in expectation between mid-level and senior and principal at Amazon. You can take the same prompt and just push them to go into specific things at different levels. So I wouldn't be surprised if it was also given to mid-level engineers, but there's certain questions that you like can't actually vary easily to make it into a mid-level question. I think I've seen startups will do it anyways. But yeah, some questions you can take them at the mid-level all the way to the senior and maybe even principal level. And so yeah, this is one that can be shown in a couple of different levels, I think. Just going through the chat again, but yeah, you can definitely get it at both. Levels, yeah. 1 million sensors reading is not a lot of data. What does the data look like? Is it just an int? I think you need to kind of you probably do want to know the latitude and the longitude. It's so again, that was a thing where it was a little bit open-ended for scale on this problem. Is like, hey, are the sensors just doing it once per day? Is it like once per hour? Are we getting like continuous data? And I think it is just an int, but if it's millions of devices, if it's going nonstop, I mean, that would definitely be a lot of data. But at so we can do some quick math here. I haven't actually done that in a while, but 1 million at once per day. It was millions, not 1 million. It said like millions. So like if we had like 5 million or millions with an S. So 1 million comes out to 10 TPS if it's evenly distributed throughout the day. 5 million comes out to then 50 TPS because it's 100,000 seconds in a day. I actually have these numbers written down somewhere so that, yeah, I'm always worried about like doing like carrying a zero wrong or something. Let's do those at once per hour. Came out to 240 and then like roughly 1250. So this number is actually pretty decent. That one is actually a pretty reasonable scale. I like these numbers over here quite a bit. I think they're rather reasonable. And it did say the max over the course. One of the requirements that's easier to miss is max and min for the whole day. All right, I'm just going to read through the chat again for another minute, and then we're probably going to go ahead and get started on the diagrams. Oh, and then of course the scale of the reads was very open-ended as well. I mean with this one it was you have some variation, but there was literally nothing specified for the read volume. And if you look at the actual prompt, like right here, yeah, literally nothing for like, is this just for like an internal thing and then they're going to pull it out of our service, then like the front end team handle scaling it out, or is this going to be for a literal weather app? It didn't actually specify weather app in the prompt that was given. So it's literally all over the place for what you can get on the read side. Yeah. All right, yeah, I'm going to read through the chat for a minute, and then we can go ahead and move into the diagram. Yeah, yep. Talk about multiple solutions for this concept each one. Are you serious? Like that would are you just guessing, or is that speculation, or is that serious? And then I was asked 1 million requiring per 5 seconds for this same prompt. Is that, did you get that scale for like 1 million over the course of 5 seconds continuously throughout the day? Okay, we can design for that too. I wasn't actually kind of planning for that, but we could also do that. Yeah, 1K TPS is rather low. It's you can't handle that with just one machine. It would make it rather boring. Oh, we have confirmation. Wow. All right. I've I've actually so you guys have known on the channel for a while. I've always gone over multiple approaches, and I was always really disappointed by how nobody else really seems to be doing this. And like I actually had done this like in one of my interviews like a year ago. I'd actually gone over multiple approaches for just the rate limiter problem, and it like apparently like blew the guy's mind. I was like you open up a book and you have like, yeah, there's a couple of different approaches for it. For rate limiter, they go over like the algorithms. There's a couple different approaches for algorithms. But yeah, I always thought that it's you know, when I make these videos, I go over, you know, multiple solutions. It drags out for like a whole 60 to 90 minutes, and sometimes you're supposed to crack these interviews in like 45 minutes. And so I didn't think that was possible to maybe try and like cram them all in there, but that would be yeah, that would be cool. I didn't know I was actually doing proper prep for the senior staff level here. Very cool. Thanks, Ton, for sharing that. I appreciate that so much. Okay, let's maybe fix up those scale numbers a little bit. So we got that, and then we have another TPS of so we got 1 million at 5 seconds comes out to you divide it by 5, that's 200K per second. So we might have 200K TPS at another volume. That would be cool. So one machine for a database can handle 10K TPS is the number I'm now going to quote. So that would come out to 20 machines at the OLTP thing. Yeah. All right, cool. I'm going to go ahead and move on to the diagrams that I don't like. I definitely want to get into this. We're going to start with a naive approach. We are going to start with a naive approach. It's going to be, oh, is this on Excel? No, it's on Medium. All right, cool. Actually, we're going to put it at Excel. We're going to do this, and we're going to zoom out a little bit. So we're going to do approach 1, naive. And it's Cassandra, and although it's naive, I am going to say some interesting stuff about it that might be really fascinating to you guys. So we will have our sensors. Oh, actually, I want to use this one. I do kind of want to color it green like my endpoints. I like to start with my entry points and exit points. Actually, I'm disgusted. I want to use the exact same color green as I got over here. It's just bugging the hell out of me. Can I see that? Okay. Let's do that. Thank you. That was bothering the hell out of me. I'm sorry. So we got our sensors over here. Our temperature sensors, specify that. Got our temperature sensors over here. We're of course going to have some kind of backend. It is the data collection backend. All right, and they are just firing off this data like crazy, apparently at like 20K TPS. And so we're seeing that it's going to be, we're going to have like a really crazy high write volume. And you need to store this data somewhere. And, you know, you might have to do some kind of transformation downstream. So you might be thinking, oh, okay, write heavy. So we're going to slap Cassandra in there. And it's going to be sensor readings DB, and we'll just do an initial capture in an OLTP database because you don't want to do full table scans on whatever the heck's going on over here. You're just going to go ahead and you're going to pop it over here. And like I mean, if you're in mid-level, it's like you're just going to be like, oh, okay, you know, Cassandra. They might not even know that Cassandra's like it uses LSM trees, so it's like really good for that. But you know, you like that. Cassandra actually has built-in integrations for MapReduce that are like really good. And so you might think, okay, we're going to go ahead and run a MapReduce job against this thing, straight against our OLTP database. So So with MapReduce in the white paper itself, it says that it is like the advantage of it is that it brings the compute to the data store. And so what that means is that with a MapReduce job, you're kind of doing it directly on your machine as an OLAP job. You are literally running it like on top of that. It's a full table scan is what you're doing, and then you can like store the results somewhere else, like in a cache or something. You might have you could have a Redis cache of the results. This is the naive approach, of course. And there you go. And then you're going to serve that up to Redis cache, or like, well, so we're going to make an image. So we're going to have some big MapReduce job or something, or we're going to build the image and we're going to store it in. It actually wouldn't be Redis. We'd have an S3 cache of results. It's the picture is over there. And so MapReduce jobs are, so Cassandra literally has some integration for MapReduce. And so you might think like, oh, this is going to be great. But when you slap a big batch job against your OLTP database like that, it's really not good, because it's going to result in a latency spike, and it could result in dropped writes coming in. It might suffocate those writes or something. It's generally, so in our case, we're not doing reads off of it. So the latency spike that you're going to get off of those OLTP transactions isn't really going to be as noticeable to the end users, because they're of course going to be they're going to be on the browser app. It's browser user checking the app. Will actually be not the browser, it would be the app. And they're going to want to pull in, actually it's S3, so you can actually pull it directly off of it. You don't, if you're doing S3, you can actually go ahead and read directly off it. So it can work kind of like a cheap CDN. So actually it could even be S3 slash CDN. Yeah, I mean, you know, it's like, oh, you know, I got my data store. I'm going to make this image and I'm going to store it in a object store, and then they can pull it straight off of it. Looks good, right? Well, OLTP, if you're running a MapReduce straight against it, it's going to result in this massive latency spike, and that's bad. Yeah. All right. I'm going to read through the comments now and see if anybody has really disagrees with why this is naive and they can actually justify it sufficiently. That would be, I'd love to hear it. But my impression is you really should not do a full table scan against your any big query. You shouldn't really be doing. Shoot, you know what? I should still have the schema specified. Yeah, I should still probably be specifying the schema. You know what? Yeah, I'll do that first, and then we can go ahead and get into the comments. But yeah, that could so we're still gonna have it partitioned by the sensor ID. And we'll say that it's sensor number 345,678. And it's the temperature is 75.4 degrees. We'll have the lat and the longitude, and that'll be negative 45.3 degrees, and we'll have 23.2 degrees. Yeah. And oh, we need the timestamp. We need the timestamp. Yeah, so we would want the most recent timestamp for each sensor ID. All right, we got 167.000.5000, and we're going to partition by this. This is going to be the partitioning key. And then this is of course going to be a sort key, or it's well, yeah, okay, yeah, that would not be enough for a primary key. So you need these two together to get a full primary key. So together these form the primary key. Okay, so with this partitioning key, you would of course avoid having, it should be a pretty even load across all of them. And then when you do that map reduce job, it's gonna hit all the partitions and all the machines. And so for the scale, we're also gonna have, 20 machines as per the scale that we wanna work off of. And that should do the trick. But again, the latency spike. Now I'm going to go through the comments and see if there's anything justifying this that is actually able to justify it properly. And yes, yes, that is the scale that I'm going to be handling. I'm happy. I'm really happy. I do these live. I was totally just gonna do this whole thing with an assumption of like no higher than like 1K TPS. Yeah, I'm really happy. I do these live. Since we are reading from 1 million sensors, and they communicate over HTTP, what will be the response format? Does it respond the reading from 1 million sensors? So device failures is really important. So yeah, this is actually a good question is, are we calling the sensors or will the sensors call us is one of the important questions. Do we call the sensors or do the sensors call us? And then you specifically asked the response format, and then I think it can just be a blank 200 OK. We don't really need to care about, I really think it should be the sensors calling us. Calling the service rather than the backend server calling the sensors. So I like this approach more. It's a little bit, yeah, I don't even really want to explore the idea of the server calling the sensors. I'd literally call it naive. I should even make a note of that. It's like the failure scenarios and the fact that you'd have to have the server running this like batch job style thing. I can even like not bad. It's like job scheduler. It's like this job scheduler approach from the server's perspective, which I don't like. And I don't know. It just, yeah. And then you'd have to have those sensors running as a web server. The sensors would have to run as a web server. And like having to treat it like a thing, like a server that just sets up an endpoint that you can call is just really weird to me. I think it would just make more sense for the sensors to be the one that is calling the server, not like no, like it would be weird if like a sensor is like running a HTTP server that can like handle GET requests and like post requests. Like a sensor doing that is just kind of weird to me, personally. Let's make sure I'm actually answering your question. Since we are reading from 1 million, they communicate over HTTP like that. Yep, I like that. Yep. I think that's even using the versioning thing. I think Alex Shu had that recent blog post about good API conventions, good API naming or proper RESTful conventions. It was cool. Maybe you're referencing that. Get what will be the response format? Does it respond the reading for all 1 million when we, well, so you have to have a request and a response. Of course, you can't just do a one-way request unless it's, I think maybe like UDP is able to do that. I'm not too familiar with stuff down the stack in networking. But yes, you are of course going to have it do a request and it will then get a response back from the server. So the request comes into here. It does a call to the sensor reading DB. The DB replies, yep, I got it, 200 okay. And then you go ahead and give that 200 okay back. And then the request format is just going to be hitting it'd be a post endpoint. You actually would not have get temperature reading. It would be a post endpoint because you're doing an update of the data. If it was the server calling the sensors instead, I guess get would kind of make sense, but then it's also kind of doing a reading live. Like it makes it like activate the sensor live and then it returns the response. And then that would of course mean that it's going to hang on the sensor for a little while it's doing that action. And then that means that you're going to have this like connection held open on the server for a while, which is weird. You're going to like have it held open for like a whole second or two, as opposed to going vice versa, where it's like maybe 100 milliseconds. Like holding a connection open on the server end is more expensive than on the client end typically. And so I would much rather have this one doing the callings. That way it's not this held open connection on that backend server for like an extended period of time. So just again, the other direction I just feel is super naive. Connection open for a more extended period of time. And it has to like hold open more stuff on the server end. Anyways, request, it's going to be a post request. And it'll have sensor ID. What did I say? It was 3, 4, 5, 6, 7, 8. And your temperature. 75.4. You can go ahead and do the lat and long. So maybe it has a GPS device attached to it. And so then maybe somebody out in the field can even just go ahead and move around a sensor or something. It could. So these are optional parameters. It can go either way with the design. It's probably kind of redundant because like you could have the sensor mounted to a wall or something. It shouldn't really move around. But it is an option. Just go ahead and send it anyways. That would of course consume extra bandwidth. So I think it would be kind of goofy to go ahead and send the lat launch over. That would make it a little bit more expensive on the server end. It just consumes more bandwidth and then also more storage space. So you could have like a cache or something that translates a sensor ID to a lat and launch direction, just over towards the server end or something. I don't care. It would even get thrown away because then you're going to turn it into a pixel XY location anyways. So I could even do, I can't cross stuff up. I'm just gonna use MD notation. So we're just gonna go ahead and cross these out. And then what about the response? Just a simple 200 okay in the server, just empty. You don't need to say anything at all. Just like, yep, thumbs up. I got your answer. I've stored it. Yep, 200 okay. That's all. Going through the messages more. If anyone is able to justify this approach, I'd love to see it. This problem is kind of similar to real-time navigation question. I haven't heard of that question. I'd love to see a prompt here. See a prompt or link for that problem. Yeah. Sorry, can you explain how does MapReduce help here? Okay. You might be mapping the sensor IDs to a pixel spot. So this is not doing a traditional. A lot of the times when I say MapReduce, I just mean a batch job. I have less experience with doing batch stuff. I haven't really had a lot of hands-on experience with like Spark or MapReduce itself. I don't think people really do MapReduce itself so much anymore. but you could do translation of sensor ID to XY pixel of the image. So that would be like the mapping step, and then in the reduce step, you might actually like create the image or something. Yeah, you don't necessarily need the map reduce job. It was more to indicate, it was more so to indicate that you're going to need to do a full table scan. And that you're also going to need the most recent timestamp for each of the sensor IDs, because you've got multiple records that each have, so like for the same sensor ID, you might have the one from, the 4,000 second mark or something, and it might have been at like 75.2 there, and you only want to see this right now for the latest data. So it's also more so that like, hey, we're going to have to do a full table scan. We not use CDC, rather talk with S3. Well, each one would then be, well, so you would it's like you have one record written, and then the DB trigger would get fired off, and then what would it do? Would it result in rescanning the whole database, or would it result in going to S3, looking at the current image, updating the one pixel of it, and then writing a new image, or writing over top of that one? While on top of that, you're getting thousands of hits per second. What was it? No, 200K times per second. This is going to be happening. And so if each one is resulting in, like, they're all going to be trying to access the same image. So it's like 200,000 times per second, you're going to be updating that image. And so it's the 200K TPS of changes to the image is the issue with trying that. Yeah. So you just write 200,000 images per second, or you could try and like, so it's like we're creating 200,000 images per second is like what might be resulting from that. Good question though. We may need time as well. I think I added the timestamp to the record. Good call out though. Yeah, I did forget that for like a whole minute or so. I think it's important to discuss what the timestamp is. Is it processing time or is it event time? Good. Yeah. Okay. Well, so I was assuming that a few seconds of variation is probably fine here. It's so it could either be the sensor time or it could be the time of receipt. I think it would probably be a good idea to use sensor time, because it could get stuck on the network for a little period of time. And in fact, in some of my other approaches, we're going to see that it's going to have even more room for variation. So you are totally right, that it's sensor time versus the server or backend timestamp. And yeah, we definitely do want to use the sensor timestamp there. If I was using the server timestamp, we wouldn't even need to send it over the wire. And I am going to send it over. Oh, I don't have the timestamp in there. Yeah. Well, there you go. Yeah, you do need to have that in there. Great call out. Yeah, great call out. You definitely want to use the sensor timestamp. So yeah, I'll even update this over there. Great catch. All right, what got what? Oh, pros and cons of each approach. Oh, that's a great idea. Okay. More accurate for any delays that could occur over network. Particularly if I throw Kafka if I throw Kafka ahead of any data store? And I'm going to do that later on. So that is a pro. And con is takes up more bandwidth with an extra int going over the network call. And then yeah, so this one is it's just vice versa on that. So I don't think we need to write that all out. Okay, let's keep going. You're doing with MapReduce job, maybe CDC can be used here. I think you would end up creating 200,000 images per second. Like how do you control access to that image? And it's unless you can turn the image into a proper CRDT or something, but like you literally have this like image file that needs to be there, you know, for this. It's S3 is it's an object store, or like with CDN or S3, like you're literally serving up a file. And if you're updating that 200,000 times, if you're trying to update it with DB triggers, it should be resulting in like trying to create a new image 200,000 times per second. I mean, you could like go ahead and no, like it's yeah, I can't really think of a lot of ways around this where you could like filter down the updates to like 2000 TPS or something. You would still need to like group up those updates to the image at some way. I do have some ideas for getting to real time, and we are going to get to that. I do have ideas for real time. We're going to get to that. It's just not right here. I'm just going to use Redis pops up, and then you're just going to read straight off Kafka. Pull versus push models. All right, got what you're doing with MapReduce, but maybe CDC. It's the same discussion as, yeah, well, I mean with the pulling from the sensor, I'm really not seeing it so much. I'm sure there's probably some way to make it advantageous. I'm not seeing it. I personally am going to call it naive. If the read volume is if the sensor data is at a really low volume, maybe you could, and then you can do retries a little bit more easily. You can have the server doing the retries, but even so, you can also have the sensor just programmed to be doing the retries instead. And then, well, I mean, that would also be better for device failure detection. That could be better for device failure detection. So yeah, okay, all right. More pros and cons for this. So server polling the devices could be better for device failure detection. It'd be like more proactive with it. But again, there's like that huge connection that just needs to like sit open on the server, which I don't like. And then retries can easily be handled from either. Okay. Yeah, that's all I'm really coming up from. This is one of the strongest arguments that I could see for it. I did have this in mind, and so you can even have that as like a separate thing that would be going on in the data warehouse. So on top of building the image, you can also check the most recent timestamp for each device. And so that was the direction that I would head for device failure detection, is just another data warehouse job to look at the most recent timestamp of each of the sensors. And I'm going to draw that later. I should hopefully remember to draw that. I think I got it written down in my notes. Yes, I do. Send 202 async processing instead of sending 200 and waiting for. I've never that I'm assuming that's an HTTP status code. I've actually literally never seen that one before. That is really cool. I would prefer not to wait for the write to complete to the DB, because what could happen there is that you can get the so if you just go ahead and send the 202 back before you do the write to the database, what could happen is the machine could actually die after returning your response, but before doing the write operation, get the plug ripped out like between those two operations, or you could just somehow, or if the database is down, what if the database is down, or like that specific node is faulty? Then and when you hit it, it returns a 400 or a 503 or something. And then instead of sending back the 202, you would have wished that you sent back a 503 or a 400 or something that would tell the sensor to retry. So I'd actually prefer if you just go ahead and stick with the 200 and don't do it async. A second reason is that it could be harder to do that because like now you have to do multi-threading, and now you have to do some async threading stuff. And in practice, I've actually never seen when I was at Amazon, our backend service actually didn't bother with even doing so much as the actor pattern from Akka. We just did basically synchronous API calls one after the other. And there was like 50 of them, and we went ahead and just did them all synchronously, basically, is what I saw. We didn't try and like thread them in any fancy way. It was just, each server was handling like 1,000, no, it was like probably 60 requests per second. But so I mean there was multi-threading going on, but it was at the request level, not like within a single request, any async processing going on. I'll go ahead and write that is that there's first of all, what if you get a dropped right to the DB? You could have retried from the sensor instead. I see the other message in the Zoom chat. I'll get to that next, and then I'll keep going down the YouTube chat. I just wanted to say that real quick. And then you can also get what is it? Multi-threading within single request on the server adds significant complexity. It would be a lot of complexity. Multi-threading is really hard, and you'd rather just not do that most of the time. The complexity alone is probably, it's a lot of the times you'd much rather throw more machines at the issue than throw complexity at the issue. It's only at when the scale is so high that the cost is significant. Like even at like hundreds of thousands of dollars per year, like a few $100,000 per year, that's not enough money to warrant the extra complexity of threading a lot of the time. It's only when it's the case of millions of dollars in savings that you care enough to go ahead and worry about multi-threading to try and squeeze out some more juice on the server side. Or if it's just really low-hanging fruit, in certain really specific cases, multi-threading, it can also make sense, but generally you don't want to try and do that. Yeah. All right, I want to look at the one in Zoom first. He's been waiting for a little while, actually. No, oh, come on. Do we need to worry about time drift here? I think we can hand wave it. I think a few seconds. Well, so it's also on the sensors themselves. So of course the sensors are not going to be perfectly synced up. I don't think so. I don't think so. It's only really for transactions that you have to worry about that. Mainly a concern for transactions, and it's in the book Understanding Distributed Systems by Roberto Vitillo. Actually, Distributed Systems by Roberto Vitillo. He had a specific thing for when it's like when is eventual consistency not good enough. When is eventual consistency not good enough? When can you not do, so it's like, when can you not do compensating transactions? Is like another idea that goes in line with it. And he said something that was like, he used the concept of, it was monotonic rights, monotonic operations means you don't need the crap that Spanner has. And in this case, and that's our case. Is that if these write operations get reordered, it doesn't make a difference. It doesn't matter which order that the sensor calls are written to the database. If they're shuffled around by even a whole minute between them, it's not really going to make a difference. When it does make a difference is, for example, stock market transactions, where it's like the difference between whether or not you buy something for $45 a share or for $45.50 a share or something. And so then it like actually has a tangible difference. If you can shuffle around the transactions and it results in a different final state for the database, that's when you start to care a little bit more about clock drift stuff. Sometimes it's not dangerous, and so you can go ahead and hand wave it anyways, but in our case, it's totally not going to make a difference. All right, probably not. Yeah, so probably not, since the data from one sensor should always have consistent. Yeah, you use the word monotonically increasing times, or you used it in relation to the word time, while in his case he used like the term monotonic operations or something. It was really hard. I could not find this information in DDIA, by the way. He gave his 2 cents on it. I think the guy that wrote database internals, it was Alex Petrov, also has some little thing that he might have written about it. But figuring this little thing out is it's really fascinating little detail that took me for a ride for a while, like a few months back. Or do we need to worry about time adjustment here too? Yeah, no, we can totally drop time drift completely. It's totally a non-concern. We don't need to worry at all. Yeah. Okay, going back down the chat, can we enqueue writes to a queue for a different approach? Let's go. You know what? I want to just kind of like come back to the chat. So you guys are thinking ahead of me. Okay, I can go ahead and start moving on a little bit. Okay, so we'll go ahead and copy paste this. I'm going to go ahead and do 2 approaches really quick before I check the chat again. So we got our approach 1, the Cassandra one, and then we're going to do 2, which is CDC of OLTP to OLAP. This is 1, and then so instead of doing this, well, so we can drop that. Have this thing, it still is going to be there, and then instead of having a MapReduce job running directly on OLTP, we're going to instead have, so we can go ahead and keep Cassandra as our solution for the OLTP database, but instead we're going to have a OLAP copy as well. And it can be something like, I don't know, Trino or Redshift. And then the MapReduce job switches from running on the OLTP over to running on the OLAP. Go ahead and bring that to the front. And now you can't see that it says OLAP. And there we go. All right. So this is one approach. I'm just going to drop it here, and then I can go ahead and move on to approach 3. So, I mean, this is a nice one. It's not too bad. No, I'm pretty sure it can scale just fine. I'm pretty sure DB triggers can scale just fine. It's just if you're doing scatter gather or like key range queries off of those DB triggers, and it like if it's a big scatter gather key range query, that's where you can't do the TB trigger. But this works just fine. And now I want to, you guys, I think really want to see that queue approach now. So I can go ahead and start to draw that next. And then we can maybe talk about real time, where I can answer more questions in the chat. You know, yeah, sure. Okay, so we're going to move on to 3, which is we're going to go ahead and use streams now. We're going to go ahead and use streams. And this is where we're going to see that thing that I said earlier about what the heck is going on there? Where did that arrow come from? Why did that pop up? It's annoying. It's not over there either. Okay, so now we can have our stream. So it's like, why is the OLTP database even there? It's like we don't even really need this OLTP database here. It's just kind of like passive. We're not even doing any reads of it. So like, why don't we just go ahead and switch over to Kafka, a stream, and that we could still go ahead and pipe the data over to the OLAP database. And Kafka can handle a higher volume of writes than Cassandra, I believe. So it might allow us to do that chunk even cheaper. And then we can go ahead and, yeah, we don't have that. And we're going to go ahead and, so Kafka is not push based. So what you would need is some task runners, some Lambda triggers in order to pull from Kafka and switch to a push, but those are batched up at 10 TPS with 1,000 messages each. So each pull, so each of these task runners is going to be pulling about 10,000 messages per second. I think that's what it was. It might actually be even higher scale. And I know they even have something called Pulsar for Kafka now that can handle like even higher volume. But so yeah, you can pull like 10. Oh, that was the limit for a shard, was 10 TPS per shard at 1,000 1,000 messages each. So you might still need 20 machines of Kafka, but there's also Pulsar or something. I'm pretty sure Kafka would be a better choice than Cassandra, I think. But we also have a couple of other options here. Is that we still might want to be dumping that into the OLAP thing for the image, but one of our requirements that we've kind of been missing so far is that max and min for the day. We hadn't really covered that anywhere. And so before we could cover that with OLAP just fine. I mean, you would also do the max and min job over here as well. I could even just have like a little box showing that showing where that's being done. So we have the max and min job, and we also have the image building job. And let's do, yeah, image. So like both of these are being done by this OLAP database right here. And there we go. While over here, I'm going to say the image building job is over here, but you can have Flink. Go ahead and have Flink reading from Kafka instead, and it would probably be a lot more, it'd probably be even better than trying to run it on, it might be a little bit more efficient than running on OLAP. So then that opens us up to another opportunity to just use Flink for storing the max min job. Do like a dotted line. That probably would have been a smarter idea for, yeah. And it's just like continuous, and it could even be updated continuously throughout the day, or you can just do a 24-hour window or something perhaps. But Flink would probably even be great for that as well. Okay, this was approach 3 is the streams. Yeah. Okay, so I still have 2 things that I really want to cover. I know I've been neglecting the chat here for a good couple of minutes. Sorry. So I still have two things I want to get to is live updates of the image and also dead sensor detection and handling, which I think I've already given enough information on it for you guys to dead sensor detection. Yeah, I think I've already given enough information on that second one for you guys to kind of have it figured out. You know what? I'll copy this up above the live chat. I think I'm a little bit less likely to forget about it over there. And then I've been neglecting you guys for a couple of minutes to knock out approach 2 and 3. Let's zoom out a little bit while I'm answering questions on these approaches. Yeah. Okay. We got nothing in the Zoom chat. I think I answered that one fine. Yeah, I think I completely answered that. And then can we answer writes to a queue? Yes, you were jumping ahead. Yeah. And then what else have we got? Would people want to know our tolerance for dropped requests from the sensors? May have missed that. I don't know. So I don't know how much the tolerance is for dropped requests. I don't know if we have to tell them how stale the reads are. Yeah, I didn't see anything about handling stale reads properly. Yeah, that could be a good question to handle. Is like maybe they could be up to 24 hours old, and then like with the batch job, if you don't, it's supposed to be giving an update every 5 seconds. And so if you haven't heard it from it in a good few hours, you could like tell somebody to like go out and figure out what's up, maybe set up a new sensor, deploy a new sensor over there in the field. And then that should prevent it from going more than 24 hours stale. That would just be another OLAP job or something that you could just run hourly or just off link. Dead sensor detection could help prevent you could call that a, what is it, SLO? And then I'm saying like maybe assume up to 24 hours. Yeah. Okay. But yeah, I didn't see anything about like what to do if you're starting to get dropped writes from a sensor. I didn't see anything. All I have is this prompt at the top that I already went over. If you want to use CDC, if you want to use CDC, then you need to do something like CQRS. I don't know if that's really necessary. Oh, you might be right. I think so CQRS is like a pattern. It's that you do your writes on one set of endpoints and your reads on a different set of endpoints. I don't think that necessarily, I think it's more of like a sanitary thing. So you could say, so you have like some data store, and then you might have your the write backend service. So we actually had something really similar to this in my team at Amazon, is that we wanted to know what code was involved in writes versus reads, because if we screwed up the reads, it was just fine. You could be back to normal within a couple of hours. You didn't have to do backfill. While if you screw up the write data, you'd have to do backfill, and then you have bad data in your database, and you might have to like refund some orders or something. But traditionally, when I think of CQRS, I think of this. where it's just separating the API endpoints and not necessarily the backend services. While you could also do, you could just entirely separate and do read optimized views is actually something that I think Martin Kleppman kind of talked about in his book. And so you could have like two different data stores, and one of them is more tailored for read optimization. And then you're doing CDC across them. To just do like CDC with a DB trigger, and then oh, I'm way zoomed out, sorry. Okay, so I think this is perfect. Like this would probably qualify as CQRS as well. And then this is a different thing. And like I said, you'd have read optimized view. And then I think these both qualify as CQRS. Boom. All right, I'm just going to leave that in the diagram, even though it's just rather off topic. It's cool. Okay, other questions. The main advantage of using pool from the sensor is the ability to easily detect down sensors more easily. Yeah, I think so. Also sampling becomes easier using pool as well. And there's the ability to scale the backend independently from the number of sensors deployed. Maybe I should try and just answer some recent questions to try and speed this up a little bit. Sampling becomes easier using pool as well. Then there's the ability to scale the backend independently from the number of sensors deployed. Oh, well, if you still want to be hitting those sensors, if you still want to be getting five, like a data point from each one every 5 seconds, you would then need to scale out the backend as well. You still have to scale them both up at the same rate. You'd have to scale up the sensors. You'd have to scale up the backend as you're deploying more sensors if you want to keep that 5 second hit rate. I'm going to skip to the most recent questions. Oh, I see some people tagging me, so I'm going to answer those two is what I'll do. And then, you know what, I'll skip to doing real-time updates of the image as well with WebSockets, and then we can maybe go through more of the comments in the chat. What's task of task jobs in approach 3? The task runners, it's I'll go over each of them a little bit at a really high level. So the task runners is, so with Kafka, it sits there. You have to pull the data out of Kafka. It doesn't push it to you. You have to pull it out. And so if you have a database, a data warehouse that you want to push that you want the data to also be in there, you have to be pushing it to it. If you had Redis pub sub here, you could get rid of the task runners completely. But we don't have those. I think Kafka is a much better approach for what we're doing than using Redis pub sub. Kafka's a lot more reliable. I generally like it a lot more for high scale. Actually, I haven't really thought about Kafka versus RabbitMQ as much, Kafka versus Redis pub sub as much. I think Redis pub sub could similarly just be sharded out. It's RabbitMQ that I wouldn't want, because RabbitMQ usually is associated with doing this stronger failure tolerance thing where it can actually horizontally scale out. You could technically go ahead and shard it, but then it wouldn't. It probably doesn't have any performance advantages that you'd see. It probably not perform as well as Kafka. Redis pub sub though, I don't know if it. I feel like Redis PubSub might not be performing as highly as Kafka. Just seems like it's really well written for scale. Redis PubSub is probably good for low latency, but it probably can't have as high throughput. I feel like Kafka is more written for high throughput, but yeah. Anyways, Kafka is great for throughput, and that's why I picked it. But you have to pull the data out, and like so, this thing needs stuff pushed to it. This thing doesn't push, so you're taking this and it's pulling the data out and pushing it into the OLAP database. So that's why the task runner is there. The MapReduce job is just me kind of indicating that you need to do the image build job. I could just kind of like delete this and yeah, I actually, that doesn't really make as much sense over here because you're not actually running OLAP on that. So you're doing the image build job there on the OLAP server. And then, so I explained this. I explained that you're going to have this job run on this database. We got Flink, that's a component. It's hosted on a thing. You're going to do max and min calculations off of that. And I didn't show where the heck to store it. I should probably get around to that too. To store max min outputs. Yeah, I mean, that's also going to need some kind of database or data store. Read optimized data store is what I meant with CQRS. Since the image is fixed at 1 million pixels, I would actually store that entirely in memory. Maybe CDNs do that under the hood. So for the second part, say that so yeah, otherwise I feel like S3 is probably fine. It's kind of like a cheap option alternative to CDNs. Otherwise, if you're specifically going for like having something stored in memory, I mean, there's like Redis, but that's more intended for, I think, like OLTP use cases than object storing. I haven't really heard of Redis being used for like serving up full objects so much. Usually you use something other than that. And then I mean, S3 serves up like a file. It's yeah, I mean, if you wanted, it's you wouldn't really like host it on a server if you're running like Spring or something. There's ways that you can go ahead and like hold something in memory, like Java Beans actually kind of do that. But they're like in the code, you like write the data stuff into your code in like the XML config files. And then so it still is on the hard disk anyways, and then it like gets loaded up into memory. But I mean, I don't think it would really make sense to like have it stored directly on the servers. So with CDNs, you can do like more like storing it closer to the users. It can bring that file closer to the users. And then I don't know, S3 seems like it would probably also be a good option. Just S3 or CDNs is probably good. If there's other specific like components that you're thinking of, go ahead and let me know. I don't know if I would actually like host it directly on the server though. Like hosting an image straight up like on a server just seems kind of weird to me. Oh, there's also Elasticache. I haven't, I'm not super familiar with Elasticache. Yeah, I think that one might also be doing like edge caching stuff. It might be a good idea here. It might actually be a bit of a CDN. And then I actually kind of want to go into the first part was with read optimized data stores, what I meant with CQRS since the image is fixed that. And then this chunk was actually related to the second part of your question. But with this, Yeah, I mean, I think those are, yeah, two different concepts. So you just kind of, you were referring more to read optimized views than CQRS. Okay, I'm happy we cleared that up though. There's so many terms that are really easy to mix up with each other. And it's I do it myself sometimes. I definitely have mixed up some terms like with Lampert timestamps and some of my other content. I've definitely like, yeah, it was even called out in DDIA like, hey, vector timestamps and Lampert timestamps are really easy to mix up. Make sure you're not doing that. And I think I still did. Yeah, cool. All right. I think I answered those. Cool. All right. I see something posted in the Zoom chat. Maybe it's a helpful link. Yeah, I'm gonna post these into the file, of course. So if you guys stumble on some articles or something while I'm watching the videos or while I'm doing the streams, I'll post whatever the heck links you guys find into the chat. That is sweet. That is cool. Yeah, Redis pub sub benchmarks are actually, you know what? I'll go ahead and pull that. I'm just so curious here because now we can compare it with I should maybe say I should put some context on here. Kafka, but Redis pubs does have the advantage for end-to-end latency. That's how I would put that. 10,000. Okay. Well, so there, I kind of shared that with you guys. Salvatore is the creator. It's the creator of Redis was commenting on that. I saw that name in there. Yeah, I saw that name in there. Wow. Hey, you know what? You really got my curiosity here. Oh, wow. All right, so latency, we got that. I'm really interested in throughput. Yeah, so latency, again, latency is getting brought up here a lot. I'm not seeing a whole, oh, there we go, throughput. Requests per second. All right, so with Kafka, I'm pretty sure a single shard can handle 10,000. And so we're seeing it hitting like maybe 8,000. And then, oh, that's the observer, not the producer. The producer cannot handle more than 1,000 requests per second. So I'm thinking I'm correct that it can't handle throughput as well as Kafka can. But I could also just be reading these graphs entirely wrong. And I see that I'm only halfway down it, and there's no way I can comprehend all this. And oh, and then there's different scenarios, and maybe yeah, right heavy, latency. Producer, okay. And then it has a higher producer volume, so I think it might have just had a steady observer volume. But again, this one's capping out at 5,000 to 6,000. That one's at 7,000. But again, I'm pretty sure that Kafka can like totally handle 10,000. I think it's like 10,000 on both sides, pretty easy because it's like if you can read 10,000 off of one shard, then it should, I think, well, I don't know. These are really useful though. Thanks a ton. I definitely appreciate it a ton. Yeah, I think I was collecting up some benchmarks in the README of the Discord channel, and I think these would actually fit in really well over there. Those would be great for me to paste in there. Yeah, thanks a ton. I appreciate it. Okay, I was gonna try and handle live updates. I wanted to handle live updates. I should definitely try and do that. Oh, fix that. Sorry, my comment wasn't clear. I was thinking more. What is it? On-demand image generation. So store the image in memory. Oh, on-demand image generation. Well, so I mean, if you're only getting so that this again is coming down to like what your volume of reads is like you can assume that like with an app, it might be like thousands per second, or we might just be generating it you're doing on-demand image generation. If you have a low TPS, I think that would be fine. Um, uh, yeah, yeah. It's push based, it's not designed for throughput. Yeah, it's like it seems like almost a like A and therefore B kind of thing. I think like because it's push based, it would not be designed for throughput, it's designed for latency. Because push based like it's totally going to get you some like really great latency numbers for end-to-end latency, but that it's totally not a proper solution for throughput. Usually these things are like one-to-one correlated, like throughput and latency, like you're going to get them both at the same time. But in this particular case, you're seeing that trade-off of throughput and latency probably. And it's kind of like rare to actually see that. And I've never really thought through that a whole bunch before. And that one's actually a great call out, is that Kafka throughput is based on message size. Single node can handle about 600 megabytes per sec. That's a lot, I think. Yeah. Wow. Okay. 100,000 messages possibly. That's crazy. 1 million sensors sending data per second. It would actually not really make any differences. So at 200K, we're yeah, it's we just have 5 times as many machines. Yeah. It just totally scales out horizontally just fine. We've at 200K TPS, it was like, okay, so we need to do some horizontal scaling for sure on those writes and make sure that we don't, like break everything at it. It was like we were already horizontally scaling out everything at that point. Yeah, it wouldn't really change the overall design. Like the diagram, like the boxes aren't really going to move around. Even if you move up to like I once saw Pinterest handles 1 billion data points per minute in their metric service, which is about 10 million TPS. And even throwing that at this, it would just still be the same boxes, and I'd just throw more machines at it. That's what this diagram is currently designed for. So it's not as high. Somebody had posted some more information in the Zoom chat. And I, of course, need to post that over here because it's very fascinating. Thanks a ton for sharing that. Wait, why did that not paste right? There we go. Nice. Okay. Thanks a ton. Since we partition by sensor ID, Cassandra just linearly scales. Point compaction might be an issue though. I'm pretty sure as well. I think they switched over to Scala. I actually have been I've been wanting to look into that for a little while. I'm pretty sure that's because they're using the LSM tree, and that they have those tombstone operations or something. Well, I mean, even without the tombstone operations, it still does do that compaction thing. and the compactions are going to result in latency spikes. And so if you're going for a consistent, really, really low latency, you're going to see those little latency spikes with compactions, I think, with LSM trees. All right, I should really be doing these live updates, the real-time thing that I said I was going to do. I'm going to go ahead and draw that right now. Live updates of the image. Okay, so we're going to take my streams approach. So we got that. And then, so we're going to do for, which is, so you got the user on their app. Let's say that they've loaded up the CDN. You got this thing loaded up. And then you got your image building thing going on just fine. You're good over there. And then what you're going to want to do is, so you got the image there, and then like you can like stream the updates into, well, okay, you can't be doing 200K forwards over the WebSocket. This was for, I was planning this approach for when we were only at like 1,000 TPS or like a few hundred TPS or something. At one of the scales, it was only 10 TPS. Yeah, one of the scales was only like 10 TPS. And so if it was that, 10 TPS, or like if it was like a countrywide thing, if it was like for like all of the United States, and then some users were just in a range, like they only care about the updates to the image for like California or Seattle or Washington. They don't care about all the other sensors throughout the country. Then they would, of course, also only need a smaller TPS of stuff getting sent to their phone. Anyways, though, a WebSocket. Yeah, so we're going to have this WebSocket. This is a horrendous idea. This is no longer the fun, easy little modification that it originally was when I thought it was only going to be 10 TPS. But I was like, WebSocket, and then you just have the backend service for live updates. It's the live updates service, which also is going to have a little WebSocket connection held as well. And then you'd have updates getting broadcast over to that WebSocket from the server. And then you just go ahead and have another, you just have another subscriber to Kafka, another thing pulling from it. I need to zoom in. You guys can probably hardly see that. I'm sorry. So then you just have another subscriber to Kafka, and then it's just going to broadcast it to all the concurrently connected users. So like maybe you just have like 100 users looking at the weather app at the same time. If it's like an unpopular weather app, like if it's like the let's say CNN has a weather service, then they also have their app. And so instead of like the weather app for all iPhones, it's just like some other weather app. And then you just go ahead and you like spit it out to you. So you'd actually do a scatter gather to all of these. Normally with design for Discord, you're targeting specific WebSockets. And so you're not just going ahead and fanning it out to literally every single live updates machine and literally every single app on everybody's phone. But in this case, you are going to be doing that. You're not targeting specific WebSockets because you're giving the same updates to everyone, was my idea. But now that we have 200K TPS, we're not going to be sending 200K TPS to your phone. So this makes it less of a cool idea. I was thinking it was 10 TPS, and I was like, sure, yeah, go ahead and just send it to the phone. Yeah, you can just go ahead and send all updates to the phone. So I was thinking once per day. So then you just, you know, while you're looking at your phone, maybe like a dozen sensors of update, and just go ahead and send them all over there. Yeah, so not quite the great idea that I had originally expected. Just going to call this approach 4 live updates. And I'm going to try and tweak it to work for our current scenario. Okay, and then so I had said that you might be able to just filter them. You might be able to filter the updates. I mean, I guess you'd have a WebSocket for each different like region of the world, or each not regional. So this is kind of like a US only app. But like you'd have US East versus West, or you could even break it down by the state or just regions. So you'd have like regional, you have specific machines for specific regions. So machines for specific regions. And so then you would have, so you got the task runner. I could pull it all in, and then, okay, you could, it would be sending the messages to, it would map the message to the appropriate server. It would map it to the appropriate server. Okay, let me go ahead and spread this out a little bit. I can go ahead and explain it a little bit more. So I'll do this with an example that involves two shards, US East and US West. And then you can just go ahead and imagine yourself what it would look like if you had, 50 shards for 50 states. So we got, move this text over here. And then we're going to do, actually, okay, so I do have that. Okay. Have the, call this US West. We're going to have the US East. So you have some that go to there, you have some that go to the other ones, and then you would just have the machine mapping context on a Java bean, or just that the mapping is just deployed with the task runner. So it just maps the region to the machine. I can actually draw that. It's similar to what I've done with Redis. It could be like a sidecar deployment. I said task runners, and it implies like an AWS Lambda function. So then you wouldn't be able to do a sidecar deployment. But of course, you can also, instead of having AWS Lambda, you can just home roll it and just set up the EC2 instances yourself and just have them polling Kafka instead. But then you would have Redis mapping of region to machine. And then this is like a sidecar deployment. I wanted to shrink it down a whole lot because that's what you usually do with these Redis mapping things, but then it would be a little bit harder to interpret. Actually, you know what? I can do this. Yeah. All the Redis mapping, and then all the context is just like not on the, yeah. All right, cool. That works. So we have that, and then we're going to draw this like that, and then we're going to do there we go. All right, so that's what I envisioned. And then you can of course chart it out pretty easily. Yeah, all right. I guess that kind of works. It can scale. Yeah, that could actually scale. If you shard the hell out of it, and then really, yeah, filter down to hyper locality. So then you, instead of like millions of sensors, you only subscribe to like 10 or 20. Um, cool. All right, I had some other stuff I wanted to get around to. I'm gonna check the live chat though. We may need to touch on data purging. Well, so the fun thing with a data warehouse is that you typically don't really have to do that. If you could do iceberg tables. Is so if when you have this like data warehouse, you do actually just have massive hard disks that you just dump data to, and you can just leave it stale for a really long amount of time. You could actually go ahead and purge data though. Yeah, I imagine that. I'm curious how much data we're actually going to get here at the 200K TPS that we were handling. Is that we've got 1, 2, 3, 4, 5 numbers involved. I was looking at this. So we got 5 numbers involved per record. You know what? I'm going to do. I know you guys can't see it. I'm sorry. Okay, I just wanted to copy and paste this. I'm going to do some really quick numbers here. All right, so we got 5 numbers. It's 4 bytes per number. So that is going to be 20 bytes per record. We've got 200K TPS. That is 400K plus a 0. So that is 4 million bytes per second. So that is 4K kilobytes or 4 megabytes per second, 100,000 seconds a day. Would mean 400K megabytes per day. So that is 400 gigabytes per day. All right, half a terabyte. I mean, yeah, this is going to fit on a hard disk just fine, but like, you know, 1 hard disk per day, you didn't have 300 hard disks filled up in a year. I think with Dremel, Google's Dremel thing that they use for BigQuery, they literally have a CPU hooked up to like 1,000 hard disks. They have thousands of hard disks per CPU for Dremel. And we're talking about like 365 hard disks per year at this rate, like absolute max. You can actually also get like a 10 terabyte hard disk or something. And so then it's not even 365 hard disks per year. It's like 36 or something. Data purging is probably a good idea, but it's you could actually probably get away with just letting it fill up for like a year and not actually care about it. Maybe a good idea though. All right. If we do CQRS, then the WebSocket read side can just update at a different rate, say 60 hertz to get a smooth. Well, so then you would have to batch it up at yeah, you would have to batch them up, and then instead of having them work in the issue is that you're not having the requests work in isolation then. And so there has to be some means of batching them up in some way. And that is tricky. So we're doing this WebSocket. So we got that. Oh, wait. You're doing a pool of 1,000 messages per second. So it almost like self-batches it. You're already batching it up. So instead of having so like I said, it would be 1,000 messages per pool. 1,000 messages per pool from Kafka. And so then you can use that in your fan out to all the machines. And what is that? So if we have 200K TPS, it would get pulled down to 200 TPS of messages. There's 200 TPS of these batched things. Is there anything else we can do? Because 200 TPS is still high. Yeah, I don't know. This is probably still, I think you'd somehow have to batch across. It's that you'd have to batch up multiple pools of the data is the issue. And I don't think you can do anything with Flink to try and batch it better than that. Flink is for finding like max and mins over like a window. It's not going to change the fact that you have thousands of data points per second getting updated that you would need. So I don't think there's anything that we can do better for batching these up than those pools from Kafka. If we had a lower volume, that would help. So if we were back down to like the 1 million or whatever the heck it was, like earlier in my problem that I had originally assumed, where it was like maybe like 1 read per day per sensor, then this would totally be enough. And we would be able to just go ahead and use that alone for batching things up. But at the full 200K TPS, I don't think that would be good enough. We would probably want something a lot smaller than that. I think we'd probably want like at least 200x smaller. So we could probably handle like 1K TPS just fine. And then 1K TPS of the writes. And what the heck would that then mean for the rate of the server reads? I'm then interested in like how often we're reading from the sensors if we're doing 1K TPS. So if we're doing 1K TPS of write operations, then it's 200 times smaller. 200 times smaller. What is that? 5 seconds times 200s, that'd be every 1,000 seconds you'd be doing a read from a sensor. Yeah, okay, so that's the conclusion I'm kind of coming off of for that. It should scale, it does scale linearly, but the issue is that it I think I mean it would just go ahead, it would just result in latency spikes. It scales linearly just fine. Do other LSM based DBs don't scale that way? No, they all scale linearly, as long as you pick the partitioning key properly. I don't recall specifically saying Cassandra doesn't scale linearly. In fact, I thought I said the other thing, which was like, hey, I could just 5x the machines if we're going to handle 5x the write volume. We update service copy consumers, then we, oh shoot, I'm sorry. There's more stuff in the Zoom chat that I missed. Shoot. Yeah, I gotta paste that over. Geez, yeah, we got some really sweet links in the Zoom chat today. So I pasted over that. And then we've got, what is it? I need to answer this question to this thing. Let me come back to that after the stuff in the Zoom chat. Blog link that briefly discussed compaction issue that Zoom Discord ran into. Here, I'll stick that over there in the YouTube chat. Okay. No, if SkylaDB, I feel like SkylaDB doesn't use an LSM tree. I feel like it would probably use a B tree. Otherwise, I don't know why they switched over to it. And it would mean that the compaction issue is not coming from the LSM trees itself. Oh, garbage collection from Java. That could be it. That could be it. It could be from the garbage collection in Java. Huh. Scala does use an LSM tree, so it was just the Java compaction stuff. That was the issue. State of the art compaction. And I think you're right. Go is always an issue with garbage collection is always an issue with Java product. I might have mixed up garbage collection and compaction. Someone else should verify. I'm just trying to share all the stuff from the Discord chat, or not Discord, the Zoom chat. I'm pretty sure all these messages get deleted after I close out these meetings, so I'd rather paste them in the text file. Plus M tree structure. What? In terms of read and space application while compaction process can help mitigate. The RUM conjecture states that the RUM conjecture. I've never heard of this thing before. Yeah, I know LSM trees are really fast writes, but I guess the B trees definitely do have some issues with they definitely are not necessarily faster for writes. They definitely can be a little slow on writes. Huh. That's yeah. Would impact SS tables on disk for more performant reads, not only for our reads then more expensive, then we'd seek cascading latency as a node tried to compact. Yeah. So that's the compactions would result in latency spikes. Okay, so maybe it's the garbage compaction and the LSM tree stuff. And maybe Scala is just better at the LSM tree stuff. Well, so anyways, I definitely need to read through this. And then I think Alex Shu even had a video on it now. Yeah, I think Alex Shu even has a video covering Switch. His stuff tends to be really high level though. And it might just be like, oh, Discord switched from Cassandra over to SkylaDB. which is fascinating. And then they solve these issues, but they can't, he won't necessarily get into the weeds of like, oh, cascading latency when a node tries to compact, or that the garbage collector is the issue. And that's what I'm really interested in. So I don't know if you'd actually see that in the Alex Shu videos. Okay, there's a question. If we make the update service Kafka consumers, then we don't need the Redis mapping. Make the Kafka consumers, if we make the update service Kafka consumers. Well, so the issue is that if a service doesn't do pools. A service doesn't traditionally do pool. Although in our case, since it has WebSockets on it, it's also not going to be a traditional web service. But like traditionally, when you're looking at a web service like Spring, it doesn't pull from things for it. It provides a response for a request. You push a request to it, and then it hands you back a response. As opposed to when you're doing pulling of a thing and then pushing it out, that's not, you're not using Spring. You're not using a traditional web framework when you're pulling stuff and then you're pushing it over somewhere. So like with this, what I see is that you have the request comes into the live update service, and then it goes ahead and it like, so you get a request that comes in, and then it does this, and then it goes ahead and gives a 200 response back. So it's actually providing responses to the task runner instead of providing responses to a end user, but you're still just handing back responses instead of doing the polling yourself. And so, I mean, you could combine these two things together, I guess, but then you would have the WebSocket server would also be doing polling of Kafka. And the thing with WebSockets is that you still have to set up the connection. You would still have to have this guy, like, so you have service discovery is that, like, I guess first you would maybe call you'd call service discovery to find a free machine. So you might first do, you know what, maybe I should just go ahead and like copy paste this. And oh, I even have it on, okay, yeah, you know what, no, I'll go ahead and use this one for detailing the service discovery stuff. I won't use the split one. Okay, so I'm going to delete it over here so that doesn't pollute the simplified diagram, but here we have that. So first, the user is going to find, it's going to call service discovery, like find a freed up service. And then it is going to go ahead and it's going to contact that service to set up a WebSocket. And it gets a response back. It's like, all right, yep, I'm going to feed you updates now. You're going to get them broadcast over to you. And so then you'll get your responses like this, these unprovoked data getting sent over to you from there. And so the way that data gets sent over is that you get a request into this service, which is replying to internal requests, not external requests from over here. And it goes ahead and sends the thing and it says 200, okay, I've sent the packet out to the customers. And so it still is a traditional request response service that you can stick up in Spring or something, as opposed to if you're doing the polling, you're not handling requests. You have to you're doing the requesting. There's nothing that provokes you. Like if you're using Spring, something has to like provoke you to do work. And so that's why I feel like it kind of makes sense to have both of these, is that having a service that is not getting provoked to do the work is just kind of like weird. And engineers aren't as used to trying to figure out how to scale those things up. And then like with WebSockets, so that's also like, hey, it's probably going to be an Erlang. or Elixir, it's probably going to be, if you have WebSockets, usually if it's a very high volume of customers and you're doing WebSockets in particular, then you're going to be using a weird language, and it's also particularly not necessarily going to be tailored for polling, I feel. And so you're doing really weird stuff with a framework that's already really weird. That's just not a good combo. Although I guess we didn't really have like a super high volume of WebSockets like Discord would. And so I guess Erlang or Elixir would not really be as necessary as it would be for those use cases. And so you could probably just use Spring, and then maybe the polling is actually something that's kind of feasible there. But yeah, that's why I feel like having these two things separate is that it's just like if you have service, traditionally those are written for doing work in response to a request. And you need something that would go ahead and do the pulling from Kafka and convert it into a push request. It's pushing a request out to you. Yeah. But yeah, I mean that is also an option. And then we don't need the Redis mapping. Okay, sorry. Then I should have stuck with this diagram for trying to draw this out. So you're doing a pull in. Oh, yeah. And then the machine would already know where it's deployed to. And so, yeah, it wouldn't need, yeah. So you're correct. It would get rid of the Redis mapping. So your question was more, yeah, that would accomplish that. And I did say that like with the Redis mapping, since this was previously AWS Lambda triggers where you can't do a co-deploy, a sidecar deployment of Redis, that would have meant that you'd have to roll your polling on your own anyways in order to do the Redis mapping. So you're correct. Like if you're going to do that, you might as well just go ahead and you might as well just go ahead and probably like if you're rolling the polling on your own, you can go ahead and have the WebSockets there too, I guess. That totally does make sense. I think that's a really strong argument. Yeah. Great call out. Okay. What you mean by update service is actually the gateway? In that case, no, we wouldn't want to put a Kafka consumer on the gateway container. I think it can go either way. I think it can go either way. So again, it's like if you have a service and it's doing work, and it depends on how much logic you're going to have on that service too. Task runners tend to have a lot of glue code. And glue code, it's just nasty stuff, and like well, so like if it's glue code, it's like you don't want to have a lot of business logic there in the task runner if you're going to do that. You'd rather, if you have a lot of business logic, you want to have it like written in like the most easy to manage way possible. The most standard way is if there's a lot of business logic, you want to be able to handle it in the most traditional way possible. And so handling work in response to requests is like the more standard way to do things. Yeah, it's a trade-off. System design is all about trade-off. I can see it either way. It was a fun discussion on that though. Okay, is there anything else I wanted to handle? I know there was at least one thing that I wanted to handle, and I just haven't really put it into formalized drawing yet, is dead sensor detection and where to store those two things. Okay. Dead sensor detection. Let's maybe do some variations on this one for the dead sensor detection is so we already got our OLAP table there. And so you would just do another job over there for nope. Okay, so dead sensor detection, you just have dead sensor detection job. And so it's just all you're doing is for each sensor, get the most recent timestamp. If it's above some threshold, that means the sensor is dead, and you should have some dude go and manually inspect it. So that would be one of those like Amazon delivery driver kinds of jobs, or warehouse worker kind of jobs. You just need somebody that goes out and manually handles the sensor and like fixes it. Yeah. Okay, where do we store the max and min outputs? So it's like once per day. You would have like, I mean, you could even have it like per region, but it's like once per day you have a max and min. So it's like 2 data points per day. And so what I would do is, you know, you can just go ahead and do PostgreSQL. So you'd probably do, well, so another thing here is like, I don't think Flink does a push. I don't think Flink does a push. So it would have to be like, you'd have to have a scheduled job. Whoops, that's not what I wanted. I think you would just have to have a like AWS Lambda for a cron job. And then it would make a request to Flink for some information for those 2 things. And it could write it to our max min data store. What I'm thinking here is just PostgreSQL. You can actually just have like a single machine here. For reading it, that's of course going to be a different story. You just do read replicas, and you'll have the date. So like we could do year, day, or month, day. So that's today. And then have the max, say 78.9. You have the min 72.3 or something. And then like it's well, so this would be the primary key. Primary key. And then like if you need to schedule if you need to scale it up, how do you do that? You just have a crap load of read replicas. And so we have all these read replicas. Oh, hello. Got a read replica and got a read replica. We're gonna stick that out over. Oh, no. Here's our read replicas. I'm going to put a dash line box around them. Label that as read replicas. Put that down like that. And we're going to draw that curved. There you go. That's how you scale it out for the user checking the app. And I guess you would kind of need to have, you can't access that directly. I don't know if I would really dump that into S3. I don't think this one makes as much sense for dumping into S3, although since it's only updated once a day, I mean, you could even stick it into some Redis, like sidecar caches. I don't know. I guess there are some tricks you do to try and speed it up a little bit more. But I think this one works kind of fine. So you'd have a request come in to the a request come in to this, it does a read, and then you get your response. There you go. Yeah, that's how I would do that. Okay, yeah, I handled all three of those now. Cool. All right, I'm going to go through the messages in the live chat, just the newer ones. If I missed anything you guys really wanted me to respond to, please just repost it again. Because I think you guys were just having might have just gotten ahead of me. Okay, update service Kafka consumer on the gateway container. The question, why do we need sockets if only there's one-way communication? Well, the sockets accomplish the one-way communication. The webhook is that's only something I think for servers that I don't think webhooks can do a push to your browser. You can do a push to a webhook is a callback. You like give it an endpoint to call you back at. So I think it's like servers you can do a callback to. Yeah, I think I think webhooks are intended more for servers. Recall there was some discussion about webhooks before on the Discord channel. I haven't had a chance to look into them a whole lot yet. I know GitHub is a really classic example of something that has some webhook stuff available. Yeah, this one does also avoid HTTP handshakes. I don't know if it just does a one-way send and there's no response required from the client when it sends over a message, but I'm pretty sure it avoids the HTTP handshakes like they were saying. Yeah, no worries if God dropped. This has been, holy crap, I went really long on this one. External communication WebSocket looks great, but for when we down, well, can we use something gRPC and batch the data? Okay, can we use something gRPC and batch the data before pulling? I don't think that gRPC doesn't do batching. It's just like a code generation thing, I think. It's more of like just RPC versus REST. At Amazon, there's Coral. Cool. So yeah, I don't think that would do any batching up for you. HTTP 2.0. I'm not familiar with that. Yeah, I'm sorry, I'm not familiar with that. I can look into that later though. Okay, we've handled everything that I was interested in. Time just totally eluded me on this one. I was not intending to go this late. That's wild. I'm going to post the diagram and the text file, of course, in a pinned comment. Yeah, all right. I think we did some pretty great work on this problem, though. I'm going to go ahead and wrap it up. Thanks a ton for joining me. I hope you guys have learned something from this. I really appreciate it. Yeah, I'll see you guys next time. Thanks again for joining me. See ya.